lesson 22. Okay, so here are the vocab. I'm just going to just skim through this. We've already talked about this already. Did we talk about, let's see, for your control group, also know that the control group is kind of, another word for it is like your baseline group. That would kind of make sense, right? So your control group, that would be another word for that. And make sure that for the placebo, that is where, the ones that have a favorable outcome for it. Okay? All right, let's see here. Yeah, it's where they have a favorable response as far as the placebo effect. Okay, next page. Trucking right along. Blocking. I wanted to add a little bit more on the blocking piece. So when you are aware of the variables that are going to influence the response, and you're not testing those and we're not testing those variables, we want to block them. Okay. Here's another thing that I added. This will separate the experiment into many different experiments and take that variable that we're not testing and we're aware that it's going to cause a response. We want to block it. Then we will put all of those people that have all of those similar variables or characteristics into one group and test within that group. So even though you're separating it, you're going to test the one that, with the ones that you want, and you're blocking the other piece. Okay? We're going to see this. Don't worry. Because I was like, huh? But yeah. I had to understand it in a scenario situation. Okay, let's get to the 4 components to a well-designed experiment. Let me scooch this so we can see. Zoom out a little bit. There you go. Should be able to see all that. Yeah. All right. So you have a comparison, a random assignment, control, and replication. So a comparison is where you use a design that compares 2 or more treatments, or at least a control group that is not getting a placebo. And this is where you're going to use a control group for your baseline. A random assignment is when you use a chance process to assign experimental units of treatments. Bless you, Caleb. Now the purpose of this is it helps to ensure that the effects of the other variables are spread evenly. So that's for the random assignment. It makes sense for control to be one of the components for a well-designed experiment, because you definitely want to keep other variables that might affect the response the same for all groups. It helps reduce the variability in the response variable. This helps, for replication, it helps balance the effect of chance. It helps as far as when you have the many experimental units in there, it helps to determine that the treatment is causing the response or just not happening as far as by pure chance.
Even through all this, you can still be wrong, right?
Well,
There could still be pure chance even if you replicate it 100 times and you
I probably would need more than that, though.
But it can still not always be correct.
Yeah. There's always that but. Yeah. Okay. All right. So now we're going to identify, and they're listed for you, so you can just, as we identify them. So we're going to identify the following within a study. So we've got experimental units, explanatory variable, response variable, and now treatments. All right, can I scooch to example 1? I'm seeing head shake. Yes? Okay. All right. So, before I scooch it up even more, it says that the teacher is interested in seeing a traditional classroom instruction produces higher test scores than virtual online classes. They give 100 AP Stat students a pretest. Then they randomly divide them into 2 groups. One group goes through the course in a traditional classroom setting, and the other group takes the course online. At the end of the school year, she tests all the students again to compare the scores. So, what, as far as identifying, what is your experimental unit in this? 100 AP Stat students, that's right. Okay. Explanatory variable, this is the generic thing that we are testing. So what would that be?
Online or traditional setting?
Right, the types of instruction. That's right. So think about explanatory, that's the generic thing that we're testing. So type of instruction. And then what are we going to measure? That's your response variable. The test scores at the end of the course. That's right. Very good. And then what were our treatments? What and what? Traditional and online. That's right. Very good. Is that too small up there? It just looks small to me. There, I'll zoom in. Okay.
No, just like trying to figure out the vocabulary means. I just
It's okay.
Let's make it.
All right. Now, increasing heart rate with exercise. So students in the AP Stat class are interested in how exercise affects heart rate. Students first measured their resting heart rate. Then students did squats for 30 seconds, 60 seconds, and 90 seconds. They squatted with no weights, 2-pound dumbbells, 5-pound dumbbells. The 36 students took part in the activity. 4 students participated in each combo of time and weights. After the exercise, they measured their heart rate, identify the 4 things listed there. Okay. Now, first thing, what is our experimental units? 36 students who took part in the activity. Okay.
What about the other 4 students?
They're part of the 36.
Yeah, that's just saying how they did it. Okay. All right. So, what is the generic thing that we're testing?
Combination of time and weights.
Yep, time and weights. That's right. I think this answer key is wrong because it's time and weight. Yeah, it should say time and weights. Ooh. It should say time and weights, not exercise. All right. What was measured?
Heart rate.
Heart rate. Good. Notice the questions I'm asking when we're talking about the explanatory and the response. Okay, this is where it's going to get a little complicated. And we can list it out once we go through, but this is kind of, when we talk about the treatments, first of all, what type of treatments did we have? because there was a lot of different ones, right? There's actually 9 levels. So what would be best is instead of writing out, let's do the table first or the diagram first, and you can see, because the first thing we did, it said we did squats for 30 seconds, 90 seconds, and 60 seconds, right? So that is this level here. Do you see that at the bottom? So the first thing we did the squats for 30, 60, and 90. All right? And those were with no weights. Because remember, time and weights is what we're looking at. And then we had, what was the weights we did? We did no weights for 30 seconds. We did 2-pound dumbbell for 30 seconds. And we did a 5-pound dumbbell for 30 seconds. So let me scooch this up for you. So that is where, so here's our time. And then here's our weight attached to each of those time increments. Or time segments, I should say. And that's what this is saying up here. The no weights, the 2 pounds, and the 5 pounds. Does that make sense? I'm taking that as a yes. Why is my... I guess because I'm on AirPlay. I don't know. Yes. I like it when I have out for delivery. Nice. Oh, they told me I wasn't going to get it until the 22nd, or 5 days early. So there's actually a total of 9 different treatments that for the time and weights. I think the diagram definitely helps to label it all out if you had to list them all out. How's that? Yes? Good? Okay. All right, here we go. Scooching? Palmer says yes. Magnus, scooching? Yes? Scooching? Okay. All right, here we go. Completely randomized design. Let me just scooch all this up. You should already have this printed out, yes? Okay, good. All right, so this is your types of experimental designs. The completely randomized is your most basic. So that's what I kind of wrote in my little side notes for that one. The only requirement is that the treatments are assigned to the groups using a random process. So that would be something that I would, which makes sense. Completely randomized design has to be a random process. Blocking, randomized block design. And then you have a match pair design. You guys can read this. I'm not going to go through all this. The matched pair design is where you have to compare, or where you're wanting to compare 2 treatments. If that makes sense. So here's your 4 steps. Okay, we're definitely going to be using these 4 steps in writing. Okay, so these 4 things is the steps that we're going to be following. So kind of think of it, I like this little piece here. Think about, write up as a recipe, and that has directions for someone else in order to recreate that exactly. Think about it that way. So do you have to be detailed? Yes. All right? So make sure that you do it exactly.
In and out before my technical appointment time. Happy Valentine's Day a little late because it's just been, we just weren't here when it was supposed to be given, so now I feel like it's really late, but I have all this candy that I have to give to my friends, so you want to be my friend today, don't you? You come by 4 o'clock if I have extra.
Oh, I just need to leave that in the video, don't I? Yeah. That's too funny. Love it. Okay. She's so funny. So 3 ways to randomly assign experimental units. Do you know what they are? You got the hat method, you got the random integer generator, right? Random number, and then you have the table of them. Remember all that? All right. So you must be able to explain exactly how your random assignment is done. Let's see, what's the next thing we're doing? Here we go.
I haven't done that in a while.
I'm not gonna do it. Just find
I'm looking at your chart right now.
I like this because it's nice and colorful, so you'll get to see, and each color is being represented for each step type. That's what I like about it, okay? All right, it's definitely nice to follow. So is texting while driving causing more accidents? That question was misworded. Is texting while driving causing more accidents?
Hypothesis.
So 40 of the students have volunteered for a study. Now, of course, she can't, it's ethically as far as you can't hey, go out and drive and text. Yeah, no. So, of course, a simulator, right, would have to be done. So this is something where that would have to happen. So the first thing we need to do is we're going to draw a diagram first. Okay? So here is what that would look like.
Do you really have to prove this in the experiment, though?
Hold on.
Like,
Couldn't you
they
just
actually
look
have
at,
to
yeah.
do this?
Couldn't you just look at past accidents?
I mean, if I'm driving with my eyes closed,
Why are
I'm
you
more
not
likely to wreck,
moving?
right?
I'm also just saying, couldn't you just look at past
Okay.
reports?
So 40 students, volunteers. Okay?
We have to do this little test.
I feel like the whole test is just
Perhaps.
gonna be 22. I think that happens.
Like, how are we even make a test?
Scales like thing.
Yeah, we should have known.
I feel like the whole test is just gonna be a failure.
All right. So the randomly assignment, you had the driving while texting and then the driving without texting. Those are your 2. And then we're going to compare the average of them as far as the number of accidents between the 2 groups. So let me show you. Well, actually, I'll let you draw this first. Make sure you leave room to write a handful of sentences. Okay? Why does it feel like we're always in here forever? I mean, we still have an hour. I know.
So,
It doesn't even matter if we have a free day, like when we were just playing cards, literally took forever.
It-
here.
Is that a Hey, I'm all about taking brain breaks, and you definitely need it. You need to have the good, bad, and the ugly with all of it to appreciate the good.
how many more weeks do we have our other break?
Like a month.
Yeah.
That's
About 6.
Not
yeah.
Probably about a month.
I think that's unethical.
Boy, just kidding, we have all March too. Just kidding. Really long
Every
break.
2 weeks.
I think we have something in March, though.
I think we have one day in March.
College
Yeah.
really does look
We
like
just we have
3
so many
days.
more breaks in the fall than we do in the spring.
Mm-hmm. I know my husband, he was so funny. He goes, when I told him that we were out yesterday, he's like, never fails. After Christmas break, you guys find more reasons to not go to school. That's what he always says.
Actually, I miss as we should.
Okay, so this first part, all right, of the steps. Notice it's in blue. It says split your volunteers into 2 treatment groups. So ours was, so we had to, definitely show, okay, we put them in the 2 different ones. We had to do a simulator, one that was driving while and one that was driving without. So you're going to write um, each volunteer's name on equally, so we're doing the hat method, on equally sized paper, place in container, mix well, and draw out the first 20 names for the treatment. So 20 did while, 20 did without. Texting while, and the remaining 20 will get the treatment driving without texting. And then this piece here for the last part, that's what we're doing. That will go at the end down here, the one that's in red. That's your last step. That's how you're explaining what you're going to compare once you gather the data. So the 4 steps, so that the red is the 4th, 3rd, 2nd, 1st. Okay? We're actually talking about the same scenario with all of the examples in this lesson. So we're not changing
What, the hot method?
the driving. Okay. How you doing?
You should know.
My brain's
It's a dragon.
So 40 students volunteered. All right, because of the ethical piece to it, you know, definitely needed a simulator for this. So 20 students drove while texting, the other 20 drove without texting. They were randomly assigned though using the hat method, right? And remember that means that the pieces of paper are all equal, blah, blah, blah. Okay, what were we measuring? Well, so we're comparing the average number of accidents between the two groups. Okay. Next example. Now it was brought to the teacher's attention that gender could be another contributing factor to the number of accidents people get into. So what type of design would be appropriate for this one?
Block.
Yep. So we're going to do a randomized block design, and we're going to block for gender. Okay?
One has the ones that are gonna wreck.
My gosh. So you're doing the exact same thing, except now you are, let me scooch this so you can see it.
3 blockers, 3 like separate materials and blockers.
Yeah.
Does this match pair design too? Oh, I know, match pair design is part of block design, sir, if you read the vocabulary.
You're reading at the
Now the writing that you're going to be doing, you would repeat the process for the males when you're writing it up. So I'm only going to show you for the females. Also too, notice that we're only going to compare within each block, not comparing the genders. So when you're comparing the average number of accidents, you're talking about the females while driving and texting and the females without. That's what you're comparing, not males and females.
How much writing is there at the bottom?
A lot.
Joy.
I mean, no different than what's up top, maybe one more sentence, but you should actually be writing for the males as well, but you don't have room for that. And you want me to scooch it up some more?
No.
Okay. that good?
Oh my God, I hate doing this.
We actually haven't had to do this in a while. You know? Make sure you make a note that you're only comparing the average number of accidents between each group, not comparing gender. So all of this for your recipe here is just talking about the females. You would also write it out and talk about the males, the same stuff.
Do we have to, or can we just say repeat?
Right, you can just say repeat for males.
So on a test, you just say, repeat the test.
Not a dumb.
On the exam, you would write it out.
Okay.
That's a lot of writing.
Shut up. The right one. Yes.
Everyone lies. If you talk wage and stuff, I will stand by that.
Huh?
Everyone last year lied. Calc wage and stuff.
And when.
Calc PC is easier than that. I mean, I have a lower grade, but it's like the concept reading that.
None of these concepts are hard, I just hate vocabulary.
Yeah, they're just like, know everything. Can't apply one thing to everything. It's stupid.
I'm gonna need you to have to like reteach me all of calc in like a week, because I don't remember any of it.
You have your video.
I'm not gonna watch that
There's
hours
90
and
videos.
hours,
Get started.
hours of
Yeah,
video.
around.
Okay.
I'll like,
You gotta put it in
I'll
the
go
word.
through my notes briefly.
I love how he says, I need to reteach them.
Yeah.
Okay.
No, she knows it. You don't. She doesn't need to take the exam.
What does that say? Texting while driving and what?
What are you?
And remaining.
No.
Yeah. And then the remaining, because you did first half, right? So first half is texting while driving, and then the other half is without.
Not even playing quizzes.
All right. So it seems like the next example, a student now brings up the fact that each student has different driving styles with many other variables that can influence the number of accidents. What design could you use to control confounding variables present in individual drivers?
Lock design, but for each of the driving styles.
Yeah, there's different ways. Go to seal.
Match pair
Match
design.
pair design.
Very
Only one we
good.
haven't.
So, can I scooch it up? Okay. Sanfield, are you good? Okay. All right. So, design match pairs. So that's by having each volunteer receive both treatments. Okay. So this one they're adding in flipping a coin to help with, we'll take care of the randomness. So let me scooch this up for you. I'll leave it right there for now. Let me scooch this. Sorry. I know it's going to look weird when you look back up. There you go. So this is all of it. Notice this little tidbit here. Repeat for all 40 volunteers. So this is for one volunteer. And please make sure you note that the coin part, that is taking care of the randomness piece for the random assignment.
No, we're learning it for fun.
Okay, Caleb.
Funny joke. We'll be really on a roll today.
Oh, so we're using random assignments to decide whether each specific volunteer gets driving while texting, or they both do it?
Don't tell me I did this 40 times.
Yeah. You see how it says repeat 40 times?
Oh,
Yeah.
I have to write all that 40 times?
That's what you would normally do, yes.
On the on the
But
exam?
notice we're just going to put repeat.
So if they had around 40 people on the exam, we got to write out 40 times. Theoretically, we wouldn't.
Oh, they
They
better.
better give me one.
I'd have like a nice little template going, you know? Repeat, repeat, repeat. Yeah, see, our other random assignment was the hat. This one is they're doing the treatments by flipping a fair coin. So heads will assign the volunteer to texting while driving first, and then the tails will tell the volunteer to drive without texting first. And then it looks like, you know, they're going to have the remaining, the other half of it later.
I don't know how somebody does this for a career, like the main takes or
This
saying
would be so miserable. They're like, I want to be a statistician when I grow up. And then they take AP statistics and immediately change their mind.
Who ever have you heard, I want to be a statistician?
Yeah, who's
Five years,
ever
you're like,
said
you know what I
that?
would be more than
Someone,
anything
because they
in the world?
exist, don't they?
I've never heard of
Someone
that.
had to say they wanted to be one of the people.
Maybe I accidentally fell into it.
Freak, do you dream of being a statistician someday?
I don't think it's something you dream of. I think it just happens on
They
accident.
have like some giant childhood childhood
No, you get the
trauma.
pay raise.
You have to pay.
They don't
money.
make crap either. They probably make less than 6 figures.
Well, Magnus, why don't you be one?
No.
Because they make-
less than
no, they
6
don't.
figures.
Yeah, Magnus,
They
you
do.
fit our
Yeah,
description
I
here.
did.
No, because like, well, yeah, if you get a high
6
degree.
figures for this?
Go look at CDC.
Yeah, because no one wants to do this.
This is terrible.
The highest
Scarcity.
Paying,
Go
the
look
highest
at
paying
CDC
entry level
jobs.
math jobs are
Economics.
like 107.
Dude, this guy's got the person who does this is probably like so loaded up on like
I thought
Adderall
it was
when
only
they this, they don't
50.
even remember the time.
No, at this point, I'd be doing math. Just-
Okay, as you are writing this down, okay? So once you've gathered your data and completed your study, then you will, what can we do with the information or conclusion that we came to be about? So the first thing you asked, did we randomly sample from the population of interest? If you can answer yes from that, then you can generalize your conclusion to the population. If no, then you cannot. Did you randomly assign the treatments to your experimental units? Yes, then you can establish a cause and effect. No, you can't establish. Okay? You guys still writing?
Yeah.
You should have to start doing this. Make it fair.
Mm-hmm.
You can see how miserable we are.
Well, well, I was. I had to stop because I can't.
sometimes I write too fast. Even my writing just gets illegible and I can't ever read it.
You're getting
No matter
flashbacks.
how illegible.
We're doing okay, you guys. It's only 10:03, so. And we're almost done. Like, we're about to hit the last page. So when you flip over, we're on the last page, okay? And there's just a handful of sentences on the back page. One for example 6 and one for 7. So this is the last diagram, so to speak. And recipe you have to write.
An hour and a half in here. Go back one slide.
Who's that in?
Mr. Simpson.
I cannot read my notes from psychology.
Oh, no, yeah. Oh, I was
like, I didn't learn
crying
anything
and
from
writing
that.
those notes. That was terrible.
He's like, I'll go slow the
I
first
never
week.
stopped since,
I was taking that class. When he said, I did too, yeah.
Oh, I did not.
The first week he's like, I'll go slow for you guys. He was going so fast the
Yeah.
first week, and I was like, overall, that is his.
He was like, welcome to college, and it was like 10 minutes, and it was 50 slides, and I was just like,
Math professors, they start on this side and they do that. And then they come back, then they erase, and then they keep going. But they don't, they erase as they go. And then they'll come back, and then they erase as they go. Yeah.
you're like, this doesn't work.
Oh my God.
I always feel like I'm behind.
Why do they do that? Why does it have to be hard? Like, why can't we
That
just
sounds like
learn it so then we actually know what's going on? And therefore can actually
have to pay.
Well, I'd
understand
rather
things.
spend-
People ask me
This
questions
one's
about
not
I'd
my
rather
the
art.
spend like an extra hour and take time to actually learn it.
All right. How are we doing? Ready? Okay. So experiments rarely randomly, I can't say that. Experiments rarely randomly choose individuals from the population, so that limits most experiments for making an inference about the whole population. It says observational studies do not randomly assign individuals to groups, so you can't make an inference about cause and effect. All right, so they gave us 2 examples on 6 and 7. What can we infer? So does playing classical music increase test scores? The teacher wants to study the effects of playing classical music while testing on her students. She randomly assigns 2 of her AP Stat classes to listen to classical music and 2 classes no music while taking an exam. Students who listened to classical music had a test average of 80.2. The students who tested without had a test average of 77.5. What conclusions can be drawn from this study? Explain.
Classical music increases test scores?
I don't think like class.
Well, we can establish cause and effect, and we can establish,
Maybe what if she just
we
gets
can
us
generalize
talk
what a
about-
population.
What has to be done first, though, in order to be a well-designed experiment? We have to have something, right, that's randomly selected. Okay? And then, all right. So can we generalize anything as far as the findings to all AP Stat students?
No.
No, we cannot, because the students were not randomly selected, right? Which is what this is saying up here, or at the top of your page. Okay? We can establish a cause and effect for these students because the students were randomly assigned to treatment groups. So they were randomly assigned in that way, so there is a cause and effect there, but you can't generalize. So the treatment groups, they were randomly assigned, but when the experiment itself was not out of the whole population. Does that make sense?
How do you randomly select again?
Remember the 3 different methods?
So,
Hat, integer, and table.
you said she randomly assigns them, so how is that not the same thing?
Yeah, but this is talking about when you're doing experiments, it has to be from the whole population.
So from all AP Stats?
Mm-hmm. Because you can't generalize your findings to all of them because they were not randomly selected from population of interest.
What if she took a hat thingy of all her AP Stat classes? Would that work or no?
The only thing she did was that she split them up amongst her classes. So that was talking about, because that's what she did for, the no music and the music. So that was the treatment part.
What if she did like a random hat thing for all the AP Stat classes? Would that work or no? Or would that still not be the entire population?
To me, is it talking about all of the students in general, or is it talking about all of the students in the school? Like, to me, it doesn't specify.
So that means what? If it doesn't specify what?
Because I would assume that there's more AP Stat students. So if she's just doing hers, it's not the whole population. It's just her classes. I would think you would be able to generalize if it was all of them.
So when it says randomly selected, doesn't that mean she used one of the things?
What do you mean?
It says she randomly selected them. So how
Only
is
the
that-
treatment groups were not, because then she just chose the classes of you're doing music, you're not doing music. But as far as the students in general, no. They were not randomly selected. Okay. Yes, no? He's already zoned out.
I
Okay.
don't know. I wasn't really. I
All
don't
right.
understand what it means.
Well, we'll talk about it later, okay? All right. Kayla, can you turn the edge that's on the side of you? Go, nope. Right there. Perfect. Good. Okay. What do we have here? Do female students spend more time studying than male students at that particular high school? AP Stat students randomly selected 100 males and 100 females and asked them how many hours a night they studied. Female students surveyed average 1.875 hours per night, and male students averaged 0.975 hours per night. What conclusions can be drawn from the study?
Yes. That's the first question, whatever it is.
Yes,
That
the total
female
population.
It is randomized.
Yeah, the students were randomly selected, right? So we can generalize about all of the high school students at the Olympia High School because the students were randomly selected from this population. So yes, we can generalize about that. However, we can't establish a cause and effect due to no treatments being randomly assigned because it was what type of a study? It was just observed, yeah.
Oh, so wait, in example 6, she does 2 of her AP Stat classes and 2 of normal classes?
Yeah, so she did the treatment part. She did randomly select that piece, but she did not as far as, I think if she would have, if she only did all of the students, I think she should have done a randomly selected part of the students in general. Then we could generalize about it.
Yeah, because also
But,
AP Stat
yeah.
requires smarter than the other classes.
Yeah.